Hello, friends. Each year, scientific studies confirm that more than 4,000 licensed python and snake farms operate in Southeast Asia, supplying skins and meat to the global supply chain. But how are millions of animals processed while still being labeled as complying with animal welfare standards? Watch until the end to see how economics, efficiency, and industrial design have silently shaped one of the world's most invisible livestock industries. Questions are constantly being asked. If millions of pythons are being farmed legally, where are they raised and how? Python farming did not emerge from culinary curiosity. It emerged from leather demand. The primary species raised by reticulated pythons and Burmese pythons are selected for size, scale pattern, and skin integrity. On modern farms, reproduction is controlled. Eggs are incubated on site, and hatchlings enter a system designed for predictability, not wilderness. A single adult female can lay 50 to over 100 eggs per cycle, allowing farms to scale quickly. Within 12 to 18 months, many snakes reach commercial size. In python farming, feeding is not random, and it is not generous. It is carefully calculated. Unlike cattle, pigs, or chickens that must be fed every day, pythons can go days, sometimes even weeks between meals. What makes them valuable to industrial farming is what happens after they eat. Scientific studies published in 2024 show that once a python feeds, its body stays in a prolonged growth mode, continuing to turn food into body mass with unusually high efficiency. In simple terms, pythons gain more weight from less food than many traditional farm animals. Even the source of that food matters. Most pythons are not fed crops grown specifically for them. Instead, they consume agricultural byproducts, discarded poultry, surplus protein, or materials unsuitable for human consumption. This means python farming does not directly compete with the human food supply, a detail that makes the system look environmentally efficient and economically appealing. From an industrial perspective, this efficiency is not a coincidence or a scientific curiosity. It is the reason the business works at all. Everything in the system, from feeding schedules to housing density, is built around maximizing that advantage. This is not wildlife being taken from nature. This is livestock production designed for output. As pythons grow, control becomes tighter. Their environment is regulated for temperature and humidity to keep growth predictable. Health checks focus less on behavior and more on skin quality, because skin, not the animal itself, is the most valuable product. Growth rates, mortality, and feed efficiency are recorded and monitored, the same way a factory tracks production numbers. By the time a python reaches processing size, it stops being treated as a pet and starts being handled as a number, counted, weighed, recorded, and moved through the system like any other unit of inventory. Once pythons leave the farm, live animals are moved to centralized processing facilities under controlled conditions to limit stress and prevent damage to the skin or meat. This stage rarely appears in marketing or public discussion, yet it plays a critical role in product quality and regulatory compliance. For pythons whose skins are destined for Europe or the United States, paperwork follows every step of the journey. Traceability records, permits, and inspections ensure the animal meets international trade requirements. At this point, the python exists simultaneously as a living organism and as a regulated commercial asset. This is where biology turns into logistics. At the factory, the purpose of the entire system becomes clear. Pythons are sorted immediately, not by where they came from, but by how they will be used. Some for high-grade skins, some for meat, others for secondary byproducts. Inside modern processing facilities, processing is fully standardized, built around hygiene, speed, and consistency. Large factories can process hundreds to thousands of pythons per day, using identical methods to ensure predictable output that meets food safety and export standards. The skin is handled immediately and with extreme precision. Even a small cut or tear can reduce a hide's value by 30 to 50%, so trained workers focus on preserving scale patterns and surface quality. After removal, skins are cleaned, cured, tanned, finished, graded, and exported. High-grade python skins are sold to fashion manufacturers in Europe and the US, where finished products often retail for $2,000, 0 cents, to over $5,000, 0 cents per item. Speed protects freshness, precision protects value, consistency keeps the system profitable. What remains is not thrown away. Studies estimate that more than 80% of a python's body weight can be used. Meat is trimmed, chilled, packaged, or further processed. Fat may be rendered and other materials enter secondary markets. Every usable part is directed somewhere. In this system, waste is failure, efficiency is survival. There's a simple reality. Python meat is largely absent from Western diets, not because it lacks nutritional value, but because it lacks acceptance. Studies show python meat is high in protein, low in fat, and farmed pythons demonstrate feed efficiencies comparable to poultry, partly by using agricultural byproducts instead of human-grade feed. Yet Western food systems prioritize more than efficiency. In the US and EU, novel meats must pass lengthy FDA, USDA, and EFSA approval processes. While consumer surveys indicate over 60% of Western consumers are unwilling to try reptile-based meats, regardless of farming conditions. Retailers, wary of ethical backlash and low demand, largely opt out. The result is a paradox. Python meat is biologically viable and environmentally competitive, but commercially frozen.
Studies show ball python meat is high in protein, low in fat, and farmed ball pythons demonstrate feed efficiencies comparable to poultry.
Until regulation, culture, and consumer trust align, it remains a technical option, not a Western market reality.
Studies show ball python meat is high in protein, low in fat, and farmed ball pythons demonstrate feed efficiency. From the farm,
Millions of pythons are already being farmed, the factories are running, and the supply chains already serve Western consumers, just not on the plate. This isn't a story meant to shock. It's about how modern systems quietly decide what becomes acceptable, what becomes profitable, and what stays invisible. When meat turns into data and skin into currency, the animal itself fades from view. And once the system is clear, it becomes harder to believe we're only buying leather or only consuming protein. Though the question isn't whether this system exists, it's whether we're comfortable with the parts of it we're trained not to see.
Hello, friend. In just 7 days, 10,000 snakeskins became a $1,800,000 0-cents jacket. What tricks do modern snakeskin factories use in their operations? Watch until the end to uncover the valuable lies The factory sits on a hardpan rise 30 miles north of Laredo, where the only shade comes from mesquite and the only sound is the steady thump of conveyor belts. A hand-lettered sign on the gate reads, "Laredo Exotic Leathers Authorized Only." Inside, the air carries salt, pine cleaner, and the faint metallic bite of chemicals. Every 30 days, 10,000 farm-raised snakes arrive in ventilated crates stacked 3 high on flatbed trailers. One of them, tagged Lot 472 and measuring 12 feet from nose to tail, will finish the week as a $5,000 0-cents jacket in a Dallas boutique. The process begins at dawn. Lot 472 is lifted from its crate by a forklift operator named Travis, 29, raised on a peanut farm outside Parasol. He scans the barcode clipped to the tail, records the weight, and wheels the crate to the euthanasia bay. A stainless steel door drops with a hollow clang. Carbon dioxide hisses through vents at a measured rate. "30 seconds later, the python hangs motionless. The method is silent, painless, and approved by the American Veterinary Medical Association. Travis repeats the cycle 333 times a day, every day the line runs. Travis hooks the lower jaw to a pneumatic arm. Rubber rollers grip just behind the skull. A rapid stream of compressed air inflates the snake's neck skin. The skin peels off in one long, unbroken tube, scales intact, and weighs 11 ounces. The cost to strip it is $60, covering power, gloves, and cleanup. The meat drops into a render bin bound for fertilizer. The hide moves forward on a stainless conveyor. The skin layer, after peeling, lands in a rotating drum filled with pale green liquor. The plant uses aldehyde tanning with glutaraldehyde and mimosa bark extract, so no chromium touches the scales. Color stays locked, texture stays supple. Each hide absorbs 50 gallons of water over a 48-hour cycle. Filtering that water to meet EPA standards adds $12 per skin to the ledger. After tanning, the hides are rinsed in reverse osmosis water and spread on perforated steel tables. Warm air at 110 degrees Fahrenheit circulates for 18 hours. Shrinkage is held to 3%. A A staking frame then clamps each skin into an octagonal jig. 8 hydraulic arms pull evenly in every direction. The scales settle flat and flash like wet coins. The finished leather is 40% lighter than cowhide and tough enough to shrug off a mesquite thorn. A laser in the cutting room traces digital patterns in 90 seconds flat. %80 of the pieces are sliced by machine. A seamstress named Shelby, 33, raised on a cotton farm near Corpus Christi, spends 20 minutes hand-stitching the collar and cuffs. The label sewn inside reads "Handcrafted in Italy," though the skin never left Texas. "70% of jackets marketed as python are actually water snakes, thinner, cheaper, and perfectly legal." The word "handcrafted" stays on the tag even when lasers did the precision work. Sustainability claims sound solid until you look for proof. A small paper CITES tag is the only ironclad receipt that the skin came from a licensed farm. No tag means no certainty. Shelby bought her own jacket for $4,200 last spring. She now shops with 3 hard rules. First, she drags a thumb across the scales because real python feels cold and firm, while polyurethane feels warm and rubbery. Second, she flips the lining and looks for the CITES tag. Third, she sticks to Texas brands such as Lucchese, Justin, and Tony Lama because the leather is tanned within a 2-hour drive and the supply chain is short enough to trace in one sitting. On day 6, Lot 472's hide is cut, stitched, and burnished to a soft sheen. On day 7, the finished jacket is folded into acid-free tissue, boxed, and loaded onto a courier truck bound for North Park Center in Dallas. The plant's digital counter clicks forward. Another crate backs up to the dock. Travis wipes sweat from his brow and waves the driver in. The line never sleeps. The math is straightforward. 10,000 snakes yield 50,000 square feet of leather. Raw cost per hide is $200. Factory cost per jacket is $300. The retail price is $5,000. Markup is 15 times. The plant clears its $1,800,000 0 cents monthly target before the last crate is unloaded. Shelby slipped her jacket on again last Saturday. She felt the chill of the scales, traced the CITES tag, and smiled. She knows exactly what she paid for and what she refused to pay for. Lot 472 is history, but the rules are set, the ledger is square, and the next truck is already idling at the gate.
Europe's largest processing factory, Danish Crown in Denmark, harvests thousands of cattle weekly at its Holsted facility. This supports Denmark's beef harvest. Where the Danish Crown handles 64% of cattle processing. The process starts with international transport. Veterinary staff check cattle for illness, vaccinations, and identification tags. They ensure only healthy animals proceed to harvest. Loading areas are quiet, shaded, and slip-resistant to reduce stress. Cattle enter ventilated steel pens for air transport, with space for movement and water access. Attendants monitor conditions during flights to ensure animals arrive ready for harvest. These steps follow EFSA 2025 guidelines, which require better housing and feeding to cut stress. After safe transport, the beef harvesting process begins with advanced technology. At Danish Crown, cattle move through low-stress lanes to the processing area. Strict protocols minimize discomfort before stunning. Carcasses hang on conveyors. Passing workstations for hide removal, organ separation and splitting. Robots and infrared sensors ensure precise cuts and quality checks. Blades adjust for size differences, and every piece is traced for supply chain transparency. This automation boosts efficiency and reduces contamination risks. Unlike the US, where growth hormones are allowed, the EU bans them, ensuring safer beef for consumers. Some animal rights groups argue harvesting harms livestock and push for plant-based options. EU beef supports US markets, including burgers, with imports up in 2025 due to trade deals. Methane emissions at 54% of the EU's man-made total remain a challenge. Biodigesters manage waste during harvest to lower environmental impact. From meat harvesting, the focus shifts to dairy production. Dairy farms in France and Germany produce 1/3 of EU milk. Hans, a farmer at Veldhoven Dairy in the Netherlands, says, "Smart collars help me care for my cows, but emissions are a concern." Cows live in spacious barns with clean bedding, ventilation, food and water. Hans checks cows daily, ensuring they are healthy and comfortable. Smart collars track activity, eating and health, cutting medication use by 20%. Rotary milking systems collect milk quickly and gently. Each cow's milk is tested automatically for bacteria and quality. EFSA 2025 rules require 13 square meters per animal and 60 centimeters of feeding space. Farmers use apps to manage feeding and breeding. AI tools, part of a $5,590,000,000 0 cents market, predict health issues early. Robots in the Netherlands handle feeding tasks. Manure is recycled as fertilizer and solar panels power farms. These efforts ensure a steady milk harvest year-round, even in tough weather. By 2034, global dairy production will grow 1.8% annually per OECD FAO, while EU beef may drop 6.7% by 2035 due to environmental pressures. Farms in France use solar panels and biodigesters to cut emissions. Compared to the US, where production stays stable in 2025, Europe leads in hormone-free harvest and welfare laws. New EU rules in 2025 protect billions of animals. Look for EU organic labels on beef and dairy at stores like Walmart. To support sustainable harvesting, your choices can drive cleaner, safer food production worldwide. Check product labels next time you shop to make a difference in how food is harvested.
Hello. Australia's beef industry is a global powerhouse, and at its heart are cutting-edge processing plants that process more than 20,000 head of cattle every day. These aren't just cutting-edge hubs, they're the future of meat production in Queensland and beyond. What's the first thing that comes to mind when you think of a processing factory? Leave a comment and follow Trending Farm's journey to see if it resonates with you. The people powering these processing factories are as impressive as the tech itself. Take John Mitchell, a facility manager at JBS Beef City in Queensland, who spent 20 years in the industry. The machines handle the heavy lifting now faster and safer than I ever dreamed, he says. Alongside him is Sarah Newen, a robotics engineer who fine-tunes the systems.